Sleep is a pretty big part of everyone's life. The average person sleeps for 8 hours a night and a third of their entire life, and that's just people. Other animals spend more time asleep. For example, the common squirrel spends 15, and brown bats sleep 19 hours a day, meaning that they only spend 5 hours awake. So what exactly is sleep? Sleep happens in cycles. Each sleep cycle is more or less 90 minutes long. In each cycle, there are 5 stages. The first one is light sleep. During this time, a sleeper can be awakened easily, and eye movement is slow. During stage 2, eye movement stops completely and brain waves begin to slow down. During stage 3, there is no muscle or eye movement. Very slow brain waves called delta waves start to appear. By stage 4, the brain is producing almost exclusively delta waves. There is still no eye or muscle movement. It is during stage 4 that bedwetting, sleepwalking, and nightmares often occur in children. The 5th stage is called REM, or rapid eye movement. The eyes begin to move rapidly, breathing is shallow, quick, and irregular, limb muscles become paralyzed, heart rate and blood pressure increase, and the body loses control over temperature, hence why it is common to awake from a nightmare sweaty and or panting. Why is sleep important? It is during sleep that the brain forms new pathways that allow us to learn and remember information. Getting sufficient sleep improves problem-solving skills and helps with attention and good decision-making. Sleep is also linked with healing the heart and blood vessels. On the flip side, not getting enough sleep can exaggerate emotional problems or mental illness, and can lead to poor decision-making and being unable to cope with unexpected or negative events. People who don't sleep enough are more at risk for getting heart disease, kidney disease, high blood pressure, diabetes, strokes, and being generally unhealthy. The University of Manchester collaborated with a fine betting company to create a very simple, barely mathematical equation. T times BT plus C divided by HA plus S plus L plus H times D. In this equation, T equals tiredness, which is calculated by the number of hours since last full night's sleep minus hours spent napping plus hours of exercise. B is bedtime and is calculated by taking the bedtime on a particular night and dividing that by a person's normal bedtime. C equals comfort and is pillow plus bedding plus mattress minus 9. The numbers for each item are determined by a rating system from 1 to 5, where 1 is extremely uncomfortable and 5 is extremely comfortable. HA equals hours awake and is calculated by how long you are normally awake per day, generally around 16 hours for people. S equals sound and does not include white noise or soothing sounds. Like comfort, sounds are rated on a 1 to 5 scale, 1 being very soft sounds and 5 being very disturbing and loud sounds. L equals light and is rated on a different scale, where 0.1 is very dull light and 2 is very bright light. H equals heat and is calculated by finding the number of degrees that the room is different from 16 or 17 degrees Celsius and dividing that number by 10. D equals duvet appropriateness for the room temperature, basically if your blanket is too thin or heavy. The article did not say how this is calculated. Obviously, there are a lot of flaws with this equation. It doesn't take into consideration hydration, nutrition, health, or any medication a person might be on. The equation is also barely mathematical. This brings us to a more complex equation for sleep, a cosine equation. S of t equals 2 cosine of 2 pi over 1.5t minus 2. The 2 pi over 1.5 can be substituted with 120 pi over capital T, where the hours have been converted to minutes. This equation represents the sleep stage S as a function of time, and how sleep cycles are each around 90 minutes. S equals sleep, and is 0 during wake time, and is -1 during the final stage of sleep, REM. Lowercase t represents the number of hours you have slept, and capital T represents your sleep cycle in minutes. Additionally, the function S of t is greater than or equal to -1 is applied to the cosine function, ensuring that a sleeper will not wake up in too deep of a sleep stage, in this case REM. This equation creates a 15-minute cushion of times when you can wake up without feeling groggy. This equation is helpful because it can be used to determine the amount of sleep we need by plugging in numbers that apply to you. But there are still more complex equations yet. Before we discuss the two-process model and other sleep equations, it is important to understand the difference between circadian and homeostatic rhythms. Circadian rhythms are defined as physical, mental, and behavioral changes that follow a roughly 24-hour cycle, responding primarily to light and darkness in an organism's environment. Basically, it's a body's natural urge to be awake when it's light out and sleep when it's dark out. This is why your sleep can be extremely disrupted if you were to be kept in a windowless room for some reason. Homeostatic rhythms is the body's natural urge to sleep and wake, where sleep deprivation leads to tiredness and the urge to sleep more. So if you were in that windowless room, you could still sleep regularly because of your homeostatic rhythms, where your sleep works like charging a phone. Throughout the day, you get more tired and sleep to recharge yourself. The next equations for sleep are based on what is called the two-process model, the homeostatic process and the circadian process. First, we're going to talk about the homeostatic process. It's based on what is called a relaxation oscillator, where the urge to sleep increases the longer you are awake and is relieved during sleep. The transition from being awake to being asleep and vice versa happens at the high and low threshold values of the sinusoidal circadian oscillator. Homeostatic pressure decreases exponentially during sleep, as demonstrated by the equation h of t equals h0 e to the t0 minus t divided by xs. The transition between waking and sleeping happens when the homeostatic pressure, represented by the first equation h of t, reaches an upper threshold of h plus t, the mean value of which is h0 plus. This is then modulated by a circadian process, c of t, as shown by the equation ht plus of t equals h0 plus a ct, and we can assume that a probably stands for acceleration. The transition between sleeping and waking happens when the homeostatic pressure h reaches a lower threshold, h minus t, which is represented by the equation h minus t equals h0 minus plus a ct. Homeostatic pressure increases exponentially during time spent being awake, as shown by the equation h equals mu plus h0 minus mu times e to the t0 minus t divided by xw. In this equation, mu is the upper asymptote, or the value that h would reach if you never switched from being awake to being asleep. There is also a lower asymptote of 0. The homeostatic process explains why you need to compensate for sleep deprivation, for example, why you want to nap after a night of minimal sleep. The homeostatic process works in harmony with the circadian process. In this process, c of t is a periodic function of the 24 hours in a day and is represented by the sinusoidal function c of t equals sine omega times t minus x. There's also a more complicated version of the equation, which is c of t equals 0.97 sine omega times t minus x plus 0.22 sine of 2 times omega times t minus x. And it goes on from there. But recent developments in science have leaned towards a new model called the Phillips and Robinson model, or the PR model. The PR model shows interactions between what are called monoaminergic neurons and neurons in the ventrolateral preoptic area of the hypothalamus of brain. Monoaminergic neurons promote waking up, while ventrolateral preoptic nerves, we'll call them VLPOs, promote falling asleep. In the PR model, CT and H of T are still representing circadian and homeostatic pressures respectively, both as functions of time. The PR model gives a function that models the firing of neurons. In this sigmoid function, meaning that its graph has a gentle S-like shape, Qmax represents the fastest possible firing rate of the neurons. V represents VLPO neurons, and theta represents the firing threshold of the neurons. But Phillips and Robinson did not throw the two-process model to the wayside. In fact, they included the circadian and homeostatic processes in their model, with the equations xh plus h equals mu qm. When awake, the monoaminergic neurons mentioned earlier fire quickly. Qm is approximately 5 to the negative 1 seconds, and the VLPO neurons fire slowly. When asleep, the monoaminergic neurons fire at about a rate of Qm equals 0 seconds to the negative 1. The switch from wake to sleep happens when Qm equals a threshold value of 1, and C of t equals cosine of omega times t minus x. These equations apply when omega equals 2 pi divided by 24 hours to the negative 1. The value x represents a shift in phases that determines the distance from the maximum circadian value. X usually turns out to be something easy to work with, indicating that the switch from sleeping to being awake happens at a fairly reasonable time. And that's the math of sleep.